Suppose we have a call center where a new call from customers happens every 2 minutes. We have 2 advisors in the call center and they need 5 minutes on average to complete each call. How many customers can they help in 2 hours? First, we need a simulation clock, so we use the Spry clock function and set it to simulate 2 hours of call center activities, which is 120 minutes. Calls can be generated by the scheduler. The rate is 1 call per 2 minutes, written as 1 divided by 2. Then we define the schedule kind from the list of values. In our case, calls are generated in regular intervals, where the first call happens at the beginning of simulation, which is defined as 2. Calls are then fed into the queue, which consists of a waiting line and 2 assistants. First, we select the input value, which is the cell with the number of calls. The average service time is 5 minutes. And we have 2 assistants for the purpose of the simulation called servers. Because the service time should be sporadic, we choose the exponential dispersion type 1 from the list of options. The function that counts the served customers is queueOutput. It uses the cell with the queue, and the second parameter is the cumulative number of events exiting from the queue, which we define from the list of values as 1. While the simulation is running, Spry recalculates these functions several times during the simulation time, once per each simulated minute. At the end of the simulated time, the functions retain their final values, such as the total number of served customers. However, if we'd like to observe our call center while the simulation is running within the simulated time, we can use the outcome function. We choose the simulation cell we want to observe, in this case, the total number of served customers. The view parameter defines the type of output. In our case, we want a timetable of all the values of the served customers together with a chart with this data series. We choose 3. Because the service time is sporadic, we are dealing with a Monte Carlo approach. That's why we need to repeat the simulation. This is easily automated in Spry. We just set the number of repetitions in the clock. Let's say we want to run the simulation 5 times. Now we run the simulation again with the 5 repetitions, and the chart displays all 5 data series. We can get some statistical elements of an observed cell, such as the average and the standard deviation, by using the outcome element of Spry. We define the cell to observe in simulation cell. For the view parameter, this time we choose statistics, 5. By choosing 1 as the last parameter, table descriptions, we will get a table with names of the statistical parameters.